Hi Hattie, so this is a quick video I'm going to do for part B for you. I just want to make sure that in the first bit, you did get A is 2g over 5. I think T was 2.4g, was it? So that is, what is that over 5? That's going to be 24 over 10, which is 12g over 5, yeah? It's the A I really need actually though, because for part B, what I really need to work out, you've got to realise in part B, that when this happens, when you get asked these kinds of questions, there's a stage 1 and a stage 2. Stage 1 is where B falls to the floor. And what stage 1 allows us to do is find the speed of B just before it hits the floor and the system changes. And then you get stage 2, which is where B is on the floor now, and A keeps moving up the plane, but the tension's completely disappeared. Because, once it's up here, and that one's down there, the string goes slack and there's no more tension. It just skids up and then maybe starts coming back down again. Now it's at that bit you need basically to use suva again and some forces, and that's the really difficult bit, stage 2. But let's firstly deal with stage 1. Now stage 1, what we're going to do is we're going to work out the speed of B and A, because they'll be going at the same speed. Work out speed of B and A just before B hits the ground. So that's what we're going to do here. Now as the system's released from rest, you've got U is 0. We know the acceleration of the system is A is 2g over 5. We know that the distance it falls is h, and we're interested in the final speed. Now this is what's hard about this question. It's just got lots and lots of letters involved. So what are we going to have here? We're going to have v squared is 2 times 2g over 5 times h, which is 4gh over 5. So v, if you like, is the square root of 4gh over 5. Now remember, that's the speed of B when it hits the ground, but it's also the speed, crucially, of A just before the system changes into stage 2. Now in stage 2, what we really need to do is find the deceleration. Now you've got to draw out a diagram for this again, I'm afraid, because the tension has disappeared. You'll just have F max going down the slope. You'll still have R up like that, and you'll have 2G down here, and you'll be required to know what 2G sine alpha is, because what we can do is we can use forces down the slope. If we take up as positive, we can use the forces down the slope, the minus F max and the minus 2G sine alpha will actually equal mass times by acceleration. And that allows us to find the deceleration. Now remember, F max is simply mu r, so that's going to be minus mu times by 2g cos alpha. And then the sine alpha is, well, we'll write down the sine alpha and the cos alpha in a second, but that's going to equal 2a. And what am I doing here? I'm trying to work out the deceleration of A as it slides up the slope, and obviously it's decelerating because it's about to turn around and go down the slope. Now that's going to give me, mu is a quarter I think, so that's actually going to be a half. Cos alpha was 4/5, so I think that's going to give me a half times 4/5 g, which is 2g over 5. This, I think sine alpha was 3/5, so that's going to be minus 6g over 5, is 2a. That comes to minus 8g over 5, halve it, I get minus 4g over 5 though. And that's my deceleration of A, and that's why I wanted it to be negative, because now I use suva again, but on A, to find out how far it's going to go up the slope. So my U is now root 4g over 5, gh over 5, because that was my original speed of A just before the system changed. And so that's going to be my initial speed after the change. My acceleration is minus 4g over 5. My distance travelled is what I'm interested in. I want it in terms of h. And my v this time is 0, because I'm looking for the point where it gets to instantaneous rest just before it starts coming back down the slope. Now if I use that, I can find s. Now s is going to be equal to, well, if I use v squared is u squared plus 2as again, I'm going to have 0 equals 4gh over 5 minus 8g over 5 s. Now if I rearrange that, I'm going to have, well, let's have it as 8g over 5s equals 4gh over 5. Cancel the 5's, cancel the g's, and you're going to have s equals h over 2. Now, what have we found out? Well, stage 1, it moves a distance h. That's bound to happen because that's going down h, so that goes up h. Stage 2, we've found as it's skidding up the plane, it's going to move a distance h over 2. And it also tells us it definitely doesn't hit the pulley, which means this distance from here to here must be greater than h plus h over 2, which is 1.5h. And I believe that is the answer. Yeah, D is greater than 1.5h. And so that's where they get that from. I hope that makes sense, Hetty. It's quite a tricky question. Best of luck with your revision. I hope the exam goes really well. All the best. Bye-bye.